This is CEABULL Design and Technologies, bringing you the very, very country edition of NACRE Robotics agricultural lineup. So this right here is a hauler robot. What I mean by hauler means it pulls stuff. I'm thinking about actually even adding a linear actuator on here to create a dump bed on this. So it is going to utilize 4 250 watt 24 volt DC motors. They're going to be on each one of these corners here. Now the way that it will turn is I'm going to have relays on the motors. It's going to reverse the polarity. Okay, so the way that it's going to turn is, since this is in a square, essentially it's going to be full power on forward on one side and full power reverse on the other. So that will make the 360 turn right there. As of right now, I got these metal grades. Actually, they kind of work out perfect. And then this is I believe it's a propane tank cover. And these are some wheels off a RC truck. Now the actual wheels are 11 inches. These ones right here are 8. So the way that it's going to be set up to keep it all in a seamless design, it's going to be built inside the box. Since I have an 11-inch wheel, realistically it's around like 10 inches, so I have about 5 inches of clearance. So with that being said, it's going to be off the ground about 5 inches. So that's not too bad for a hauling robot. Now, since I'm going to be having 4 250 watt 24 volt batteries, that's 1,000 watts worth of power. And with that setup, that can easily haul, I mean, at max 700 pounds on something like this. But realistically, you're not going to bog this thing down, you know? So I would say 350 pounds, 400 max. 400 max on this thing, you know, if you're going to be having it drive around all day. So if you have that battery set up, it's going to be nice. So I would say a good 4.5 hours, you know, with a decent battery. I was going to do 4 batteries, you know, one for each wheel. But if one battery dies down, then, you know, it'll be turning sideways or going like that. I'm just going to use one dedicated battery, left and right. So how is the intelligence of this robot even done? Because it's going to be autonomous. So what I have here is a little paper, little 3-dimensional architecture of what my brain box will look like, and I call it the Pearl. So on here, on this left side right here, and in this thickness of this gap is a stack of a Raspberry Pi 5 with the cooler, with a 13 millimeter extension for the GPIO pins, and then a SIM 7600A, the little communication little chip, the little module on that, and then a 3.5-inch LCD screen. That's what's in that square stack right there, that rectangle stack. That other big one right there, that's a sweet little 12,000 milliamp 12 volt battery that I found. And this is a Raspberry Pi 5. Down here on the bottom, that's a Husky Lens 2. Then that's a ArduCam 1080p night vision camera. Then an MPU little gyroscope. Then up on top of that is the, I want to say the radar, the radar scanner. It's a HLK 24.5 gigahertz radar that it can track 3 objects at a time, and it does, I think, 10 scans per every millisecond. So I think it'll do like 30 scans per every second. Then up on top of here, there'll be what's called a gravity offline voice recognition module, and that gives you the ability to, you know, talk to it, give it a voice command, an animal command, whatever, you know, any type of sound command, a clap, a snap, a ringtone, you know, your favorite song, whatever you want to do, that'll be connected to it. So it actually kind of sits like this, because this has a touchscreen, because this has it's a single board Linux computer. So that single board Linux computer, you know, having that touchscreen is kind of nice, because the whole purpose of this is to do this. Take it off, okay? And then go to your next robot and then put it in there. So what I'm creating is a whole entire lineup. But this right here is the brain. This right here is the pearl. This right here is the central nervous system of the whole entire lineup. So it takes a base, you plug the brain into it, and now it becomes an autonomous robot. Just like that. It sounds simple. I make it sound simple because I've, researched all the parts that I'll be using. I'll be using an ESP32S3 for my microcontroller. So the Raspberry Pi 5 will be actually sending a signal to the ESP32S3, which will actually be attached to this robot itself. So obviously that's 5-volt power with the Raspberry Pi 5, 24-volt power with the motors. Obviously that's conflicting voltage. That's why I have that stupid big battery setup right there, because with that big battery setup, it'll run that Pi with that vision, with the cellular communication, with transferring power to the ESP32 for about 12 hours. So that right there eliminates having to do voltage conversions, buck converters, all that different stuff for transferring power for a 24 volt up to a 12 volt and hoping that we're not going to get no voltage spikes from the motors. Screw that. So basically what this creates is, imagine this as your brand new truck. It is no different from a truck from 2000, okay? A truck from 1985. It's still a mechanical vehicle. The only thing that is different is that ECU and that infotainment system right there. That's what gives it the brains. That's all it is. It's a big computer on wheels. So, and with that Raspberry Pi 5 and the ESP32S3, they have Wi-Fi communication and they have Bluetooth. So with that being said, eventually, if I had, let's say, 5 of these, they'll all be able to communicate in a swarm form. And since it has a SIM chip in it, it has the GPS module in it. So I can drive this all the way around a 60-acre field. So it can go all the way out there, because most of the time, yeah, you can connect with Wi-Fi or whatever, but you're gonna get to that gate and that's it, if you're lucky, and that's going to the house. So, and you wanna get out there, you wanna go to a barn, you go check all these fences and stuff. Yeah. So, a dedicated battery to the Raspberry Pi 5, 12 hours at least. That's plenty of time, for something like this. I don't see somebody, working it to death. I mean, it's gonna pull, it'll actually pull, like a sprayer, because if you have, let's say, like a 10-gallon sprayer, okay, every gallon is 8 pounds, so that's 80 pounds right there, plus the weight of the robot itself. So you have to take that into consideration. Another thing too is speed. It's gonna go maybe 5.5 miles an hour, which that's perfect for something that's gonna be carrying, a couple sacks of feed. It's gonna carry your toolbox. It's gonna, maybe you can sit on it and drive you around. You can put a tub on top of that, seal it, send it down the road, because you have GPS latitude and longitude waypoint locations, and you can create a perimeter. Well, instead of creating a big square perimeter, you create a long tunnel one, and it stays in that. It's like a bowling alley with the bumpers up, so it stays right into there. I know this sounds like a lot of shit just for looking at a plastic box and a rubber wheel, but literally this is about a month every single day of research, planning this, running with AI, VS Code, getting all these together, and just literally waiting to hit the button to purchase all the chips. So it's ready to go. Drag, drop, copy, paste the best I can, script kiddie this, and see what happens. If it works good, might be able to sell a couple of these, and then go bigger and go bigger. Because I do have in mind a full-size one, a full-size tractor, and I have that price around $325,000. So I do have a big future in mind, starting with this little hunk of shit, little shit box. Call it the holler. NACRE Robotics. CEABULL.com. NACRE.com.